Hey yo, what's up, YouTube? It's your boy JOSHABRAHAM Ine. And the time is 11:30. We should be starting a bit early, but hey, fuck it, man, fuck it, fuck it. Like it is. Grade number one. So I was doing this part of example 9, and let me tell you, that part was. I have to find the molar in Delphi. What? Delphi of product minus reactant. Uh-huh. That's for the product. I don't know. It should be 653 plus. Minus and minus gives plus. What are you talking, boy? What are you talking, boy? Yeah, that is the answer. But for CO2. No. No, no, no. That 4 gets cancelled with the CO2, with the 6 CO2 in the case of glucose. So, wow. Let this bag go out. That is so weird. I don't even have anyone to ask or anywhere to ask. Mm, fermentation. Fermentation of glucose. Glucose fermentation is an anaerobic breakdown of glucose into other compounds, primarily by microorganisms like yeast. In alcoholic fermentation, a single glucose. No, 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 no. I want to know. Delphi, Delphi, Delphi. Minus 72 kilojoules. Let me see the question again. 6 combustion of ethanol and glucose release molar enthalpy of 674. Respectively, calculate the molar enthalpy for the process of fermentation in joule per mole. Mm-hmm. I think this is the correct answer, and we were given molar enthalpy, and we were asked to find the enthalpy in joules per mole. Mole. Like, according to the equation, that is the correct answer. Uh-huh. Again, it is not minus 326, it is the plus 326. Again, it's not because we are reversing the given equation. Oh, wasting time. I have, according to my timetable, I should be starting with example 11 within 12. And I'm still on 9. That's not good. It's not good, eh? 8. Oh, no, why am I... Now what you gonna do? Yeah. Okay. Could you... when not reversing Because if that's the case, then it makes sense. We do reverse the ethanol combustion and applying S law because the fermentation for ethanol is being produced, not burned. Known combustion reaction. Yeah, fermentation reaction. Ethanol is being formed, not burned, so it reversed the combustion reaction. Yeah, the signs change. Yes. How? What? What? It's now plus? So now it's the enthalpy of fermentation is now product plus reactant. ChatGPT, you're hallucinating right now. Now it's reactant plus product. What? We're adding the enthalpy changes of the two reactions that combine to form fermentation reaction. The addition cancels common species. Yeah, that is correct. Now, that's fermentation. Combine the enthalpies.
Just feiert Geburtstag mit fantastischen Angeboten. Spare bis zu 60% auf viele Matratzen, Bettdecken und Kopfkissen. Kauf zum Beispiel diese Matratze für nur 240 € und spare 60%.
Get stuff.
Just
I have to watch 20 seconds of ad.
So this video is going to be all about so using those two reactions, how can we calculate them in such a way to get the enthalpy for this reaction? And that's how we're going to do it. So we need to focus on the right stuff. So in reaction 1 and 2, you want to focus on the reactants and products that appear only once in those two reactions. For example, nitrogen gas is only found in equation 1, not in equation 2. So you want to focus on N2. Hydrogen gas, it's found in both of these two equations. So you do not want to focus on H2. If you do, you're going to make your life a lot harder. So notice that nitrogen gas is on the left side, but we want it to be on the right side. And we need a coefficient of 2 in front of it. So what I'm going to do is I'm going to reverse this reaction and multiply it by 2. Whenever you reverse a reaction, you got to change the sign. And if you multiply this reaction by 2, you need to multiply the enthalpy change by 2.
Okay, I know all those.
So I'm going to have 100 water molecules on the right side. Here we only have 1 on the left. So we need to reverse it and multiply by 6. 6 water. Now, since we add equation 1 and 2 to get this reaction, to calculate the enthalpy change of that reaction according to Hess's law, we just need to add these values. So it's 184 plus
Okay, we just
enthalpy
add,
change
that's
of a
it.
reaction.
Okay, I was right. So it's just, you just add. That's where I made the mistake. You just add. Let me charge my phone. You just add that shit. So I have another I'll ask DeepSeek. Where is it? Stream, content, producer. Oh no. Oh no. So I just add, okay, for the next question, how is those? Given are the following. reaction enthalpy is at 25 degrees Celsius. Nitrogen plus oxygen, nitrogen monoxide plus oxygen gives nitrogen dioxide. Nitrogen dioxide plus gives nitrogen pentoxide. Then nitrogen. Okay, stoichiometrically balanced equation number 2. Stoichiometrically, like, yeah, it is balanceable, right? We put 2 here, we got 4, and we get 1.5. Or we put 4, we put 2, and we put 2 here. Yeah. Calculate the molar and molar reaction heat at constant volume for reaction 2. Calculate the molar enthalpy of reaction, molar enthalpy of formation of nitrogen pentoxide using equation. Molar enthalpy of formation for using equation 1, 2, and 3, as well as they provided data. Okay. It is doable, right? It should be doable. Let's go step by step and break down example 10 so it is easier to follow. Given the reaction for enthalpy at 25 degrees Celsius. Balance equation, yeah, it is balanceable. Yeah, for it is doable. So the equation is 4NO2 plus, yeah. Part B, molar enthalpy reaction. To calculate the reaction enthalpy, we use Hess's law. We reverse this. Reaction 2, reaction 1. Combine the reactions. We want to produce 2, start with N2 plus 5O2 gives 2N2O5. Combination of uh, a combination of reaction 3 to 1 and N2 plus 5O2 gives 2 N2O5. I guess I don't know. I don't know about that one. I still don't understand how did you all come up with that equation. Multiply reaction 1 by 2 to match 4 and O2. 4 and O2 plus 2O2 gives 4 and O2. Multiply. Reaction 3 gives 2 NO from we need 4 NO. Reaction 2, sum of H of the steps leading from reactant to products. Molar enthalpy of reaction, molar enthalpy of formation of N2O5. Okay. It's raining? Nah. Molar Adelphi formation of N2O5. Standard Adelphi formation for elements in standard states. Adelphi formation is enthalpy of reaction of 2 plus 4 times enthalpy of formation of nitrogen dioxide. 2 times 4 times, yeah. Enthalpy of reaction 2 by 2. What? I did not know this formula. It's 1209. God damn it. I'll start writing. You gotta start writing the answers. Why is that bitch? So what we do here is for product that's 653.32 plus minus of 674. Minus 20.68 kilocalories per mole, right? Yep. Now to joule, converting that to joules. I need to see get out of here. You did not convert to joules per mole. How do you convert to joules per mole? Joules per mole for minus 20.68 into 4184 joules per mole, which is minus 86.6 kilojoules per mole. That's a big number. I don't know if it's correct, but I feel like that's correct. Example 10. Fuck, I forgot the question. Let me write the question. So the reactions are 2 times NO gas plus O2 gas plus 2 times NO2 gas, enthalpy of formation minus 114.1 kilojoules per mole. Second one, which is answer to the first part of the question, which is X times NO2 plus Y times O2 gives Z times N2O5 minus 110.2 kilojoules per mole. Now for the third equation, N2 gas plus O2 gas plus 2 times NO2 NO gas gives enthalpy of whoa. I was too stupid to recognize what was going on. Gives 2 times NO gas. Yeah. And that's the enthalpy formation. Enthalpy formation delta HFM equals 180.5 kilojoules per mole. Yep. It's the answer. Oh no. Okay, let's I do the first one. The second one, calculate the molar reaction heat at constant. Okay. Could you once again show me the answer to B, for example 10. Where are yo? Boom, 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 boom. Mm-hmm. Mm-hmm. Mm-hmm.
Rabbit Brotherhood.
I just want to see how this looks like. Just a minute, YouTube. Just a minute. Okay, we're back. I was just checking out something. Don't worry about it. Don't worry about it. Let's carefully solve example 10, part B, calculating the molar reaction heat for reaction 2 using Hess's law. Given reaction 2 balanced, other reactions, we want delta H for reaction 2, I understand that. We have to find the molar heat reaction, okay. Express 2 in terms of 1 and 3. Reaction 2 produces 4 NO2. Reaction 2 requires 4 NO2. I don't think they produce. Huh? Huh? Yeah. They don't produce, they require. So you make the Figaro, Figaro, Figaro. Figaro, 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 Figaro. Whoa, that was 1.35 gigabytes. To get 4NO on the above step, oh, we use reaction 3 multiplied by 2. Uh-huh. And combine steps to get 4NO2. So we change change the direction of 2N2 plus 2O2 gives 4NO2 plus 4 times NO plus 2 times O2 gives 4NO2. Okay, so combining that equation we get okay, we're skipping the NO. I understand that. So 2N2 plus both the oxygen, these two get cancelled? Uh, and 4 times NO2. So 361. Okay, 180 into 2. 361 minus. Why are we, or is it like, okay. Okay, well, it's a negative, so. Oh, that's 132 kilojoules. Add reaction 2 to form N2O5. The total H, delta H from elements, total delta H from elements to N2O5 is 2N2 plus 5O2. Uh-huh. Okay. So delta H for 2 is the difference between delta H for the formation of 4NO2. Delta H is the delta H for 2 is the difference between delta H for the formation of 4 times NO2. So this minus this, what? For formation of this minus the formation of, okay. (132) plus delta H of 2. We do know what enthalpy are we given right now? It's a long way to go. It's a long, long way to go. A long, long way to go, go, go. A long way to go. Is that? I'm sorry. Whoa. Connected. Using experimentate. I need to give this. Like, dude, you should read this. Mm-hmm. How long has it been, OBS? 1 hour. Should I follow my timetable or should I take that break? I start with sequence analysis at 1. Mm-hmm. Given the reactions, we are tasked to calculating the molar and depth of reaction for, let's go step by step. NO2 plus O2. Yeah. His law. We get the. That's not what we got last time. Wait. What was this? What was this 132? Combine the what? No. I don't want that. Okay, I'm at example number 10. I'm gonna take the break. YouTube, peace out. I'll be starting within 20 minutes. I'll be starting with sequence analysis.